Welcome back to another JavaScript tutorial. Today, we're solving an interesting mathematical problem using JavaScript. Given an integer, find the largest value of n such that the sum of natural numbers from 1 to n is less than or equal to the given integer. This problem combines iteration, summation, making it a practical example of applying loops in JavaScript. We'll also discuss the logic behind the solution and walk through some test cases to solidify our understanding. Let's dive in. Let's break down the problem. Our goal is to determine the largest integer, n, such that the sum of the numbers from 1 to n does not exceed the given input integer. For example, if the input is 11, the largest n is 4 because 1 plus 2 plus 3 plus 4 is equal to 10, which is less than or equal to 11. This is a common scenario in programming challenges where cumulative sums are used. We'll use a loop to iteratively calculate the sum and stop when it exceeds the input value. This is the JavaScript implementation of our solution. The function starts with two variables, Sn, which tracks the cumulative sum, and I, which is our counter for natural numbers. Inside the while loop, we add I to the sum Sn and then increment I. The loop continues until the sum exceeds the input value. Once the loop ends, we return I minus 2 because the last iteration would have exceeded the last input value. For example, if the input is 15, the loop runs until the sum becomes 16, and then we adjust by subtracting 2 to get the correct result of 5. Let's walk through the steps of the program. First, we initialize two variables, Sn, to store the cumulative sum, and I to act as the counter for natural numbers. We then use a while loop to keep adding I to Sn until Sn exceeds the input value. Once the loop ends, adjust I by subtracting 2. This accounts for the overshoot in the final iteration. We then return the adjusted value of I, which represents the largest n, satisfying the condition. Here are two examples to demonstrate the program's logic. For an input of 11, the loop runs until the sum reaches 15. After adjusting, the result is n is equal to 4. For an input of 15, the loop ends when the sum equals 15, and the result is 5. These examples show how the loop and adjustment steps work together to produce accurate results. The ES6 version of the code is more concise, but retains the same logic. By using let instead of var, we ensure proper scoping variables. The logic remains identical. Accumulate the sum in Sn, increment I, and return the adjusted value after the loop ends. Let's analyze one more example with the input of 20. The loop accumulates the sum until it reaches 21, which exceeds the input. After adjusting, the result is n is equal to 5, showing the largest sequence where the sum does not exceed 20. To summarize, this program finds the largest n, such that the sum of natural numbers from 1 to n is less than or equal to a given input. It is efficient, straightforward, with applications in both theoretical and practical scenarios. Thank you for watching. If you enjoyed this video, Please make sure to like, share, and subscribe for more JavaScript tutorials. I'll see you in the next one.